Hello, welcome back. So we're going to complete our discussion of stacking queues with a challenge. Write a MyStackInt class and implement the push, pop, and peek operations of that class. Here's a hint. Use a list or a linked list for internal implementation. Pause the video and we'll return with my solution. So let's review my solution to implementing a stack with a push, pop, and a peek operation. So I have an internal linked list here, private member variable called list, declared as a linked list. Remember, a linked list links elements rather than having a set block. I think it's probably better for the stack, but you could have used a list as well. You can make it work. So let's look at the push operation. So we add first. Remember, last in, first out. So we're going to always add to the first, and then we always want to remove from the first. So that's what the pop does. So we RC, this gets the first element in the list. Then we remove the first element of the list, so there's a pop, and then we return it. The peek operation, essentially the same as a pop, but we don't remove in the middle. And there we have it. So main stack test, and we can see 190, 1,290, 490, 122, and what we expect, last in, first out, 122 to come out first. So let's take a look at this. I'll put a breakpoint right here. We'll run it. Push the 4 integers. Can't iterate over it. The stack here that I've just implemented is not IEnumerable, unlike the built-in stack operation, so we can't iterate over it. We can only do the 3 operations that we've defined here, no interface here. Pop, pop, pop. Let's trace into this one until we watch it. Return the first one, element. That's value's 190. Then remove it. Here. We're going to do the pop one too many times, just like we did last time. We get the invalid operation exception. And there we have it, our implementation of the stack of integers. All right, so we did challenge one. I showed you my MyStackInt class, and I implemented push, pop, and peek. And I used a linked list for the internal implementation. Challenge 2. What if I wanted a stack of primitives, other types of primitives like a double or a bool, or object stack like student? I could copy MyStackInt and change the data type everywhere. So I'd have MyStackDouble, MyStackBool, MyStackStudent. The logic of the stack is not changed, just that everywhere that the int is specified, we would change the data type. That's doable, but probably not desirable. It's error prone and it's a lot of work in some cases, especially if you have complex internal logic. It's better if we write it as a generic. So we've used generics, list primarily, and you've seen the list, angle bracket, and you put the type there that you're going to replace. But they're fairly easy to write as well, generics. So for challenge 2, we're going to write stack as a generic. We're going to change MyStackInt to MyStackT, and this creates a generic class. So the T here is a stand-in for a type. T is commonly used, but it's not required. It can be any legal identifier. This is also called the dummy type, the stand-in type. So then you copy MyStackInt, change it to MyStackT, and then replace int. Everywhere int is specified, so it was a stack of integers, replace it with a T. And so when the compiler sees MyStackInt, MyStackDouble, MyStackStudent, it will automatically duplicate the code and replace the dummy type with the actual type. So you're using the compiler to copy code, much easier and much more reliable. So pause the video at this point, and I'll come back with my solution. So let's review real quick my solution to MyStackInt, what we previously viewed. And you can see there's an integer here, there's an integer here, 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 and here, here, and here. So everywhere that integer appears, if I had manually copied this code and said change it to a double, I'd have to say MyStackDouble and then replace int with double everywhere. So let's take a look at the generic of this. So the generic class for MyStack, so not MyStackInt anymore, but MyStack angle bracket T. Again, this T is called the dummy parameter. Then I replace everywhere that int occurred before with that T, the stand-in type. Here, 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 here. So this is saying return T, return this. Linked list is also this way. Here we have a previous existing generic that we're actually using, and we're filling in with a T. And then stack test here. And we see this familiar syntax, should be familiar from using lists. So we use MyStack and we specify the int type here. And we then proceed to push these integers onto the stack and then pop them off. So I'll just run it real quick. And here we have it. And it behaves exactly as did before. And we have a generic, much more useful. Okay, very quickly, I duplicated my stack test here, and I changed this from an integer to a double just to prove that the generic aspect of my stack is working. Here I push some doubles onto the stack. We'll run it. You can see now we have the stack behavior, but with doubles instead of integers. I didn't have to duplicate the code. The compiler did it for me. So it doesn't, when the compiler sees a generic, it remembers it, but it doesn't generate code. And then when it sees the actual use of the generic, at this point it creates this class, double, here in this case, filling out every place that it sees the T with a double this time. So that's the creation of the generic. Very valuable. Before we go, I want to review the credits for these set of lectures on C# collections. The first one listed there, my lectures depended heavily on for both the discussion and the diagram, and then the link list. The second list there is where, the second citation there is where I got the link list from. So thank you very much for reviewing this set of lectures on C# collections.